want to look at this question, which says that an insurance company estimated that 30% of all automobile accidents were partly caused by weather conditions and 20% involved bodily injury. Further, of those accidents that involved bodily injury, 40% were partly caused by weather conditions. So let's look at before we actually proceed with the questions, let's define the events we're interested in, right? Here we're interested, sorry, let's just change the color. Here we're interested in two events, right? So here we're going to let W. So we're interested in two things over here. Automobile accident that's partly caused by weather conditions, and whether the automobile accidents involve bodily injury, right? So we're interested in two events here. So let W be automobile accident partly caused by weather conditions. That's the first event we're interested in. So we can just first define that. And we're going to define I as automobile accident involved bodily injury. So these are the two events in this question that we want to look at involved. Now let's write down the information given to us before we actually, so what we're given is this side. So we're given number one. So we're told that insurance company estimated that 30% of all automobile accidents were partly caused by weather conditions. So we're told the probability of W is 0.3, and this is over here. Let's just highlight this. So this is what we're told, this, right? And then we're told that and that 20% of all automobile accidents involve bodily injury. So we're told probability of I is 0.2, right? So this is the information given to us over here. So first we're just defining our events and looking at all the information given to us, right? That's what we're doing first before we can actually proceed with the question. So now we're also given a conditional probability where we're given the probability, we're told that of those accidents, right, that involve bodily injury. So given that there was bodily injury, 40% were caused by weather conditions. So we're given probability W given I is 0.4, right? Because see, it says of those accidents that involve bodily injury. So given bodily injury, uh, the probability that it was caused by weather conditions is 40%, right? So this is a conditional probability that were given, because see, it says of those accidents that involve bodily injury. So you're given that there is bodily injury. So given that, you're told K, the probability it was caused by weather conditions, right? So this is 40% here, right? So this is the conditional probability given to us. Okay. So let's do part A. Part A asks us, what is the probability that we randomly choose an accident? Both was partly caused by weather conditions. Both was partly caused and involved bodily injury, right? So this is, wait, let me just erase this. We can just highlight this. That would be better. Uh, so let's just highlight, oh, sorry, my bad. Uh, right, no, oh, sorry. Okay, so let's just, now we can highlight this, and the keyword here is and, right? Remember, and means intersection, right? So we want to find probability of W and I. That's what the question is asking us. And like we just mentioned, that and okay, let's just use this because we used that over there. And means intersection, right? So what we are interested in finding is the probability of W and I. So I can write this as probability W intersection I, because just like or means union and means intersection. And here now we'll apply our multiplicative rule. So over here we're given probability of W given I. So we can use a multiplicative rule and write this as probability W given I into probability of I. So because we want to find a probability involving and means intersection, we'll apply the multiplicative rule here. Multiplicative rule. Right, so we're going to apply the multiplicative rule here, and this would be probability W given I is basically given to us as 0.4 and probability of I is 0.2. So it is 0.08, this probability. Right, so the next part asks us to determine whether W and I are independent. So let's do that now. So the next part is, are W and I independent? Right, so now let's recall two events, A and B are, first let's look at in general. What do you mean by independence? Then we can apply it to the case. Two events A and B are independent if and only if the following equivalent conditions hold. Right, so the following equivalent, here keep in mind the word equivalent, we'll look into this. Equivalent conditions hold. What are the conditions? Right, so probability of A given B is equal to probability of A. So conditional probability is the same as unconditional probability. Probability of B given A is probability of B, and the probability of the intersection, so probability of A and B is probability of A times probability of B. The comma means and or intersection, right? So if I'm finding the probability of A and B, it's just simply the product of the individual probabilities, right? This only holds true in independence. In general, it's the multiplicative rule that we used in part A, right? In general, when you're not sure whether they're independent or dependent, like in part A, we do not know that. We're actually determining this in part B, right? You have to, in general, whenever you're finding a probability involving and, you have to apply the multiplicative rule, right? Just like probability of A and B is probability of A given B into probability of B, right? But if you know they're independent, this is what we're going to determine in part B, then the joint, then if you're finding the probability of A and B, you can just write it as a product of the individual probabilities, right? So this is a special case of the multiplicative rule in the case where A and B are independent. So this comma just means and or intersection, right? So this is in general. Now over here, a key thing that we need to look at before we actually apply it to our case, the word equivalent. This is what we need to focus on, and let's see why we need to focus on this now. So because of the word equivalent, so now because all these conditions are equivalent, so all of them imply one another. Since all conditions imply one another, if we prove any one of the conditions, right? So you just need to prove any one, right? You don't have to prove all three. If we prove any one, so the key word is any one of these conditions, we have shown A and B independent because all of these conditions are equivalent. They all imply one another. So if you prove any one of these conditions, we have shown A and B are independent. So you don't need to show all three. If you show any one is true, we've shown A and B are independent because all of them are equivalent. They all imply one another. So one is true, all are true, right? And if we disprove any one, right? If we show any one is not true, if we disprove any one, again, you just need to show one is not true. We have shown they're dependent because they all imply one another, they're equivalent. If one is not true, then neither are going to be true. We have shown A and B. So just keep in mind whenever you are trying to show, trying to test our, whenever you're trying to test whether two events are independent or not. So there are three equivalent conditions we can use, and but you only need to either prove one of these to show they're independent, or you need to disprove any one of these to show they're not independent. Let's apply it to this example now. Okay, in this case, note. In this case, let's note something. We're given some information, right? Recall we found probability of W. We're told probability of W given I is 0.4. It's given over here. So this is given, right? While probability of W, again, this is given is 0.3, right? This is something that you're told. This is already told in the question, right? Probability of W is 0.3 and probability of W given I is 0.4. Since probability of W given I is not equal to probability of W and I are not independent, they're dependent, right? And I are not independent, rather they're dependent. Like we said, we just need to disprove one of these, right? Because all of those conditions are equivalent, we just need to show one is not true to show they're not independent, right? So we just shown that one condition is not true. So this means they're not independent. Alternatively, because we could have checked another condition as well. We could have shown another way we could have done this was because there are three conditions, right? You can choose to prove any one of these to show they're independent, or you can disprove any one of these to show they're dependent. we could have shown, we just found probability of W and I using the multiplicative rule is 0.08 from part A. We just found this using the multiplicative rule from part A. Probability of W given I is 0.08. Probability of W times probability of I, however, is 0.03. Again, this information is given to us 0.2, 0.03, and 0.2 is given, right? It's given like in the question. Right, so we've shown, we're trying to see whether it's equal to the product or not. It's 0.06. Since probability of W and I remember this comma means and or intersection is not equal to probability, matlab you can't write this and probability as a product of the individual probabilities. W and I are not independent. So you could have shown this also. You could have shown the third one also, but in that case, you would have had to find the conditional probability of I given W, which we don't have already. So, you can just use the information given to you, right? The three equivalent conditions, you can either show probability of W given I is not equal to probability of W, which we showed here. You could have shown probability of I given W is not equal to probability of I, but then we would have had to find probability of I given W. We don't have to do that. We can just use the information given to us. You could have also used the probability W9 that you found in part A and show that it's not equal. In this case, it's not equal to the product of the individual probabilities. The key thing over here is showing one of these conditions is not true is enough. One of these conditions, you don't have to show all three or two. You just need to show okay, one condition is not true, and then you have proven they're not independent. So one of these conditions is not true is enough. So this is how you can test whether two events are independent or not. Just if you prove one, if you're able to prove one of these, they're independent. If you're able to disprove any one of these, they're dependent.